welcome back to the Deep Dive. And, as of today, May 17, 2026, it really feels like the entire architecture of the AI boom is just, well, actively fracturing.
Yeah, fracturing is definitely the right word for it.
Right. I mean, we're watching the historic Microsoft and OpenAI alliance quietly bleed out. We've got former Apple designers building rival hardware to undercut their own partners.
And venture capitalists throwing these billion-dollar seed rounds at startups that have literally existed for a few weeks.
Exactly. It's like the blueprints are being ripped up and rewritten overnight. And our mission for you today is to unpack this massive stack of sources we've gathered.
Which is quite a stack.
It really is. We're looking at everything from high-level geopolitical strategy, the fracturing of big tech alliances, this mass exodus of top talent forming these so-called neo-labs.
Right, all the way down to the granular bare metal level of how GPUs are actually processing tokens.
Yeah, and how these autonomous agents are being corralled. But, what's fascinating is that while all these stories seem totally separate, like a geopolitical white paper, a corporate lawsuit, a CUDA theme optimization, they are all fundamentally connected.
They are. It all traces back to one single thing, which is the desperate, incredibly high-stakes race to control compute.
Compute and the cages necessary to contain autonomous intelligence, right?
Exactly. The
Yeah.
physical bottleneck and the software containment.
So let's start with the geopolitical reality driving all this panic, because it really sets the stage. We have this newly released white paper from Anthropic.
Titled 2028, Two Scenarios for Global AI Leadership.
Right. And before we go any further, I need to make a really clear impartiality disclaimer for you listening. We are going to be exploring Anthropic's stated views here, their arguments, and their projections regarding the U.S. and China.
Yeah, we're doing this purely to convey the ideas that are actually in the source material.
Exactly. We are absolutely not taking any political sides here, and we aren't endorsing these viewpoints. We're just impartially unpacking what Anthropic published so you can understand the arguments that are currently shaping these trillion-dollar policies.
Which is crucial because Anthropic's core argument is it's uncompromising. They argue that the U.S. and its allies must maintain a 12 to 24-month lead in frontier AI capabilities over authoritarian regimes.
And they project that by 2028, we hit the era of transformative AI. I mean, the phrase they use is a country of geniuses in a data center.
Which is such a striking way to phrase it.
It really is. It shifts the whole paradigm. We aren't talking about chatbots anymore. A country of geniuses in a data center implies this compounding aggregate intellectual output of an entire nation of experts, all operating at the speed of silicon.
Right, in a single server farm. It's the industrialization of discovery. And to ground that, Anthropic points to what they call their wake-up call.
Oh, the Mythos preview model.
Yeah, the one released in April 2026. They gave this model to the engineering team at Firefox, and with access to Mythos, Firefox autonomously fixed 20 times more security bugs in a single month than their monthly average for all of 2025.
Wait, so it patched more vulnerabilities in 30 days than the human team did in a year?
Exactly. 20 times the monthly average.
That introduces a terrifying dual-use dilemma. If you have an AI that hunts down and patches vulnerabilities 20 times faster, the inverse has to be true.
Absolutely. You suddenly have an automated cyber weapon that can discover and exploit 0 days 20 times faster.
So the defensive shield is inherently an offensive sword.
And that's the exact national security threat Anthropic is highlighting. If a model crosses a new threshold in autonomous targeting or 0-day discovery, the regime that controls it can deploy it in weeks.
Right. The traditional military R&D cycle just compresses to zero, and the only thing preventing a dead heat race right now is compute.
The physical semiconductors, yeah. Democracies maintain their lead through advanced chips. Anthropic points out that Huawei, China's domestic hardware champion, is projected to produce just 4% of NVIDIA's aggregate compute in 2026.
Just 4%.
Yeah, measured in total processing performance. And by 2027, they project that drops to 2%.
Wow. But if they only have 4% of the global compute, how are the Chinese AI labs staying competitive? Because they definitely are.
They are, despite the export controls. They're staying at the near frontier through these massive workarounds. The first being illicit compute access.
Smuggling.
Smuggling chips on a huge scale. The paper actually cites the Supermicro co-founder who was recently charged with diverting $2.5 billion in servers.
$2.5 billion. That's not a small operation.
Not at all.
Yeah.
And they're also using foreign data centers in Southeast Asia.
Oh, the classic cloud loophole. You don't need to physically smuggle the server if you can just rent the instance remotely.
Precisely. But the second workaround is arguably much worse for the U.S. lead. It's the industrialization of distillation attacks.
Right, distillation. Let's break this down for anyone not deep in the model training weeds. Distillation is basically harvesting the outputs of a massive U.S. frontier model to train a smaller model for incredibly cheap.
Yeah, you're free riding on the foundational research.
It's like, think of it this way. It's like spending $1 billion to invent a revolutionary new recipe in a high-tech kitchen.
Okay.
And then a rival chef just buys a $20 plate of your food, reverse engineers the ingredients by casting it, and starts serving the exact same dish across the street the next day.
That's a perfect analogy. They harvest the reasoning chains, the code generation, all that pristine synthetic data from models like Claude or GPT, and use it to replicate the capabilities.
But I have to push back on Anthropic here. If open-weight models exist, and distillation is really that easy, is Anthropic's dream of a locked-in 24-month lead actually realistic? Or is it just wishful thinking?
Well, Anthropic's counter-argument is that you still need a minimum threshold of compute to run those distillation training runs.
So even the cheap knockoff requires a factory.
Exactly. Which sets up their two 2028 scenarios. Scenario 1 is democracies successfully defending the compute advantage, setting the global rules, and seeing unprecedented economic growth.
And Scenario 2?
Scenario 2 is a neck-and-neck race. The export controls fail, authoritarian regimes use cheap infrastructure to drive global adoption, and the rules are dictated by authoritarian AI.
So it's a stark binary. And it all relies on maintaining a unified front. But, and this is the crazy part, if you look at the U.S. tech titans right now, you wouldn't know unity was the goal at all.
Oh, the alliances are actively falling apart.
The consolidation phase of the early 2020s is over. We're in the fragmentation phase. And the biggest story here is Microsoft's shadow procurement.
They are quietly searching for an OpenAI replacement.
Which is wild. They poured $13 billion into OpenAI. But look at the April 27, 2026 amendment to their contract.
Yeah, that amendment ended Microsoft's exclusive license to OpenAI's models.
But the bigger detail, they entirely removed the AGI clause.
Right, which used to say that if OpenAI achieved artificial general intelligence, Microsoft's commercial rights to that specific tech would be severely restricted.
The fact that they mutually agreed to delete that clause just shows Microsoft no longer views OpenAI as the sole steward of humanity's future. They just view them as a vendor.
And Microsoft is internally mobilizing. They built the MAI superintelligence team, led by Mustafa Suleyman.
And they're shipping fast. In April 2026, they ship MAI Transcribe 1, Voice 1, and Image 2.
With the target of a full frontier LLM by 2027. But they're also looking externally. They looked at Cursor, the code generation startup.
Right. Cursor hit $2 billion ARR in 3 years. Microsoft was circling them, but backed off because of regulatory fears, right? Since they already own GitHub Copilot.
Exactly. And the moment they backed off, SpaceX XAI swooped in with a $60 billion option.
And a $10 billion breakup fee, just to make sure Microsoft couldn't counteroffer.
So now, Microsoft is eyeing Inception. It's a Stanford spin-out doing diffusion-based language models.
Wait, diffusion? Like how Midjourney does images, starting with noise and resolving the whole picture at once?
Yes, applying that to text. Processing over 1,000 tokens a second in parallel.
Why pivot to diffusion, though? I mean, it's like Microsoft paid for a lavish $13 billion wedding with OpenAI and then immediately started quietly shopping for a new spouse with a completely different architecture.
Because autoregressive models have sequential bottlenecks. Microsoft wants agents in every Word doc and Excel macro on Earth. They need speeds that sequential generation might never reach.
That makes sense. But Microsoft isn't the only bridge burning. We have to talk about OpenAI and Apple.
The fallout from the WWDC 2024 announcement. OpenAI is actually preparing for legal action against Apple.
Because OpenAI took this massive leap of faith integrating ChatGPT into iOS, thinking they'd get millions of premium subscribers.
And instead, Apple buried the features. The subscription conversions have been abysmal.
But Apple is mad too, right? They have grievances over OpenAI's privacy standards.
And over OpenAI's push into hardware, OpenAI hired Jony Ive, Apple's former design chief, to build an AI device.
Which Apple obviously sees as a direct threat. But, Apple has a long history of alienating partners.
Yeah.
Look at Google Maps in 2012, or Adobe Flash in 2010, or Spotify.
Yeah, they use partners until they don't need them. And ironically, Apple is now paying Google $1 billion a year for Gemini infrastructure.
The irony is rich, so that corporations are breaking apart, but it's not just them. The top human talent is leaving the big labs to form this new ecosystem we're calling the Neo Labs.
And the seed rounds are staggering. Billion-dollar seed rounds.
Let's list a few. Igor Babushkin, an XAI co-founder, is raising $1 billion for River AI at a $5 billion valuation.
Incorporating in Nevada, led by General Catalyst.
And he's putting in $100 million of his own money. Then you have David Silver, the former DeepMind reinforcement learning lead.
He's partnering with NVIDIA for his new startup, Ineffable Intelligence, backed by a $1.1 billion seed round.
Plus, Recursive Superintelligence raising $650 million and AMI Labs raising $1 billion. Why are these guys getting this much money right out of the gate?
Because they aren't building another ChatGPT, they are building Superlearners.
Which means a shift to reinforcement learning.
Exactly. David Silver actually said, researchers have largely solved the easier problem of AI, how to build systems that know all the things humans already know.
Right, the supervised learning on internet data.
Yeah. He says, now we need to solve the harder problem, how to build systems that discover new knowledge for themselves.
Learning through trial and error. But, tying this back to Anthropic's paper, if these models are learning through autonomous trial and error, doesn't that make them inherently more dangerous?
It definitely raises the alignment risk.
Right. Like, is this unpredictable discovery process exactly the kind of innovation the U.S. needs to keep that 24-month lead? Or is it a massive security vulnerability?
It's the ultimate double-edged sword. If you have super learners operating via trial and error, you are firmly entering the era of agentic AI.
And a model making thousands of autonomous decisions needs a highly controlled, cost-effective environment to work in. It can't just be loose.
Which brings us to the next part of the stack, corralling the autonomous agents. The development environments are evolving rapidly. Look at Cursor cloud agents.
Right, because a single repo agent is useless in a real enterprise. Cursor is upgrading them to multi-repo environments so they understand complex microservices.
And they introduced this environment configuration as code feature.
Wait, how does that work?
They use Docker files with native build secrets, so the agent can authenticate into private registries without the API keys ever being exposed to the agent's internal reasoning logs.
That's incredibly secure. And I saw they use layer caching, which makes image rebuilds like 70% faster.
Plus, strict security governance. Immutable audit logs and scoped egress, so the agent can only access a strict allow list of external IP addresses.
So even if it goes rogue, it can't exfiltrate your code. But securing the infrastructure is one thing. You also have to control the actual logic of the agent, right?
Yeah. Which is where Google's open source GenKit middleware comes in. It's designed to intercept, extend, and harden agentic apps mid-flight.
How does it intercept the thought process?
Through 3 specific hooks. The first is the generate hook. Every time the agent generates a token, the middleware injects dynamic context or safety constraints silently.
So it abstracts the safety away from the core prompt. What's the second hook?
The model hook. If the API rate limits or there's a transient error, this hook intercepts it and executes retries or fallbacks to cheaper models so the agent's loop doesn't just crash.
And the third one has to be the human kill switch.
It is the tool hook. It provides human-in-the-loop sandboxing. If an agent tries to execute a sensitive tool, the hook traps it and requires cryptographic human approval.
That's vital. But what if the agent just gets hopelessly confused? You know, it's not malicious, it's just making bad decisions.
Yeah.
Digging through raw API logs to debug an AI mine seems impossible.
That's exactly why Raindrop Workshop was built. It's the local debugger that agents have been missing.
Because it live streams the traces, right?
Yeah, every token, every tool call, every decision branch, it streams it without polling. But the really wild feature is their self-healing evil loop.
This blew my mind. Explain how this works with Claude code.
Okay, so you write a deterministic evil a test case. Raindrop runs the agent. If the agent fails, Raindrop takes the massive trace of the agent's flawed reasoning, feeds it to Claude code, and Claude autonomously rewrites the agent's code to fix the bug.
AI fixing AI psychological bugs.
Yeah.
That's insane. But this exposes a huge problem. The bill.
The token cost.
Yeah, an agent looping and analyzing trace files consumes millions of tokens. It'll bankrupt you.
Which is why OpenSQL is so crucial. It cuts token spend by 60 to 80%.
How? You can't just tell an agent to think less.
They use ML model routing. A lightweight classifier intercepted the task, analyzes the keyword patterns and semantic embeddings, and if it's a simple query, it routes it to a dirt-cheap local model.
Oh, saving the expensive frontier models only for deep logic.
Mm.
But they also fix the context window waste with that new memory architecture.
A human-like four-tier memory architecture.
All right, let's break that down because I love this. It really is like a human brain. The first tier is working memory.
Which is strictly for the current task at hand. It's volatile.
Yeah, it's like the sticky note on your monitor. Then you have episodic memory.
Which stores the experience across different sessions, the causal history of what worked and what failed.
Exactly, like your personal diary. Then tier 3 is semantic memory.
The persistent facts, the rules, the database IPs.
Like your college textbook.
Mhm.
And finally, raw memory, which is just the immutable audit log for retraining. But the coolest part is the memory dream consolidation.
Yes, every 24 hours, it restructures the scattered episodic memories into dense semantic facts, completely offline.
It literally sleeps to consolidate its experiences.
Yeah.
But I have to ask, if we need tools like Raindrop just to figure out what our own AI is thinking, and we're building four-tier memory structures that dream, are these agents getting too complex for human oversight?
It's a very real anxiety. We're building software wrappers around increasingly organic acting intelligence. But ultimately, all of this open Squella agents, ineffable superlearners, it all runs on the bare metal.
The GPUs, the most highly contested resource on Earth. And we have to talk about how the underlying silicon is being optimized, starting with Datadog's Toto 2.0.
This is a breakthrough in scaling time series foundation models. They scaled it from 4 million to 2.5 billion parameters.
And time series forecasting is different from language.
Yeah.
It's predicting numerical data streams, like server loads or temperatures. Historically, if you scaled a time series model up, it would just saturate and flatline.
But Toto 2.0 is the first one that improves reliably just by making it bigger. There is no saturation at 2.5 billion. It completely dominates the boom, gift evil, and time benchmarks.
And that's because of contiguous patch masking, right? CPM.
Exactly. Before, the model had to forecast step by step. Minute 1, minute 2, minute 3.
Which takes forever.
But CPM allows the model to predict the entire forecast in a single parallel pass.
So a massive 313 million parameter Toto model is now as fast as the tiny 120 million parameter Chronos 2 model.
Yeah, with incredible long horizon stability up to 8,192 steps into the future.
That is a massive leap. But even with architectural tricks, the ultimate speed limit is always how the CPU and GPU coordinate. Which brings us to the Hugging Face deep dive on LLM inference.
Specifically, synchronous versus asynchronous batching.
Right, so quick primer on continuous batching. It relies on three things. The KV cache, which saves compute by storing previous key value states.
Chumped prefill, which splits massive prompts so they don't crash the GPU memory.
And ragged batching with dynamic scheduling, which strips out all the empty padding waste. But Hugging Face found a huge problem.
Synchronous batching forces the CPU and GPU to take turns. The GPU sits completely idle for nearly 24% of the time while the CPU updates the batch.
24% of the most expensive hardware on Earth, just doing nothing. It's like imagine a restaurant kitchen. Synchronous batching is like the master chef, which is the GPU, refusing to cook until the prep cook, the CPU, finishes dicing the onions.
And then the prep cook stands around doing nothing while the meat cooks.
Exactly. It's incredibly wasteful. So the solution is asynchronous batching, having them work at the exact same time.
And they achieve this using CDA streams and events. They use 3 non-default streams.
Okay, walk me through the streams.
First is the H2D stream, host to device. This copies data from the CPU to the GPU. Second is the compute stream, which does the actual math.
And third is D2H, device to host, bringing the results back. But if they all run at once, don't the data packets collide?
That's what events are for. They act as tickets, enforcing the order so the GPU compute stream won't start until it receives the event ticket saying the H2D transfer is done.
Oh, so the GPU manages itself without waiting for the CPU to micromanage it. But wait, what about the race condition? If the CPU is preparing batch n plus 1 while the GPU is still crunching batch n, they can't share the same memory.
They can't, so they created a memory pool with 2 slots, slot A and slot B. The GPU works on A while the CPU prepares B.
But in continuous batching, a user's prompt in batch n needs to continue into batch n plus 1. How does the CPU prep slot B if the GPU hasn't even output the token from batch n yet?
That is the carryover solution.
Huh.
The CPU puts a 0 placeholder in slot B and injects a carryover mask.
A routing instruction.
Yes, it tells the GPU, when you finish your math, bypass the CPU completely, and copy your final token directly over this placeholder 0 before you start the next batch.
That is brilliant. And the result of this asynchronous overlap.
GPU active time increases to 99.4%, and you get a 22% generation speedup.
With absolutely no new kernels or model changes, just pure software optimization.
It's incredible.
It really is. And I think that's the perfect synthesis for everything we've covered today. I mean, look at the scope of this. We started with the geopolitical fate of the world hanging on access to physical compute.
Then we watched megacorporations tear up their alliances over model control.
We saw the top human minds leave to build superlearners with billion-dollar checks. We explored the middleware cages being built to control these autonomous agents.
And ended down inside the silicon itself, watching the CPU and GPU finally learn to work at the same time.
Yeah. And I want to leave you listening with a final provocative thought based on all of this. We see the U.S. government and giant corporations playing this trillion-dollar game of chess to hoard physical GPU chips, right?
Assuming hardware is the ultimate choke point.
Exactly. But at the exact same time, open source developers are inventing things like asynchronous batching, OpenSCHooler memory routing, Toto 2.0 single-pass masking. These are software optimizations that effectively multiply the power of existing chips for free.
They circumvent the physical bottleneck entirely.
So if software efficiency continues to outpace hardware manufacturing, who really holds the ultimate power in the AI arms race? Is it the nation that hoards the most silicon, or the rogue developer who figures out how to do 100 times more with less?
That is the trillion-dollar question.
It really is. Something to mull over. Thank you for joining us on this deep dive, and keep questioning the architecture of the future.